Hello, everyone. We'll be waiting our 5 minutes um, after the clock to start our meeting, as usual.
Hello, do you hear me? Okay, perfect.
Yes, I can hear you.
And we can hear you, Alex. And by the way, thank you for generating the request for meeting in Dublin, just in time.
Yes, yes. Well, thank you for the reminder. I had it in my mind for some time. Like last time we discussed the duration. I have to do that. I have to do that. And I saw your email today. I'm like, okay, I'm doing it now.
No, because this was this Friday, right? So we cannot delay too much.
Yeah, exactly. So yeah, thank you. So just a couple of more minutes, and we are starting the meeting at 5 minutes past 4. For note taking, I've posted the link. It's of course the regular link, and you will notice that we have our the meeting number is number 16, but the regular number is number 13. But in the scheduling process, I submitted like a series of meetings, and they started from next week, and then from the next time, and I said, okay, I'm going to put I scheduled the last one today, and so the numbering, like the IETF numbers them in the order that you request the interim meetings. So we're having interim number 16 today. Next time will be number 13. So don't get too confused. So with this, it is time. So it's 5 minutes past the hour. So hello everyone. Welcome to this interim meeting. So this is an virtual interim meeting of the SCHC working group, and it is an official IETF meeting, and as such, all IETF policies apply. So these are policies on various topics such as patents or code of conduct. So this is a note. Well, please take time to read it and to read all the documents that are listed here, all the BCPs that are listed. Most notably, by participating, you agree to follow IETF processes and policies. If you are aware that any IETF contribution is covered by patents or patent applications that are owned or controlled by you or your sponsor, you must disclose that fact or not participate in the discussion. There are some other points, of course, so the whole text applies, and of course you agree to work respectfully with other participants. And if there are any issues, of course, you should contact the ombuds team, or you can come to the chairs if that's easier and appropriate. So this being said, this is the agenda for today. So we have two main items for today. The first one is a new draft on the SCHC FEC fragment rule format, and a second discussion which is on the SCHC architecture. So we'll keep in the hour, of course. Do you have any other points or items that you would like to discuss? No, I'm not hearing anything, so we can continue. And with this, so the working group item, the working group documents are advancing. So we started last week. The working group call for adoption of the document, which is SCHC for ICMP, for ICMP v6. So it is still the draft as it is of today. It's still called draft Barthel SCHC OAM, but in the final submission, of course, the title will be SCHC for ICMP, ICMP v6. And so please send your +1 on the mailing list. I know it's been a document, so it's a document we've been discussing it quite some time now, but all the there were never big issues with that. They had a couple of discussion points, but they were addressed by the authors. So just send your +1, and so that we can, if you agree with that, so that we can adopt the document. And with this, I will give the word to Alejandro, Javier Alejandro, so who is going to present the SCHC FEC fragment rule format. So.
Yeah, do you hear me? Do you hear me well? I hope so. Okay, I don't hear anyone, so I guess it's okay. So this is the first draft proposal for the FAQ functionality for SCHC. It was co-authored by Alexander Cui, which is our collaborating activity, and myself. So we can start. Next slide, please.
You can switch to slides.
Yeah, sorry. Okay, so this will be a very short presentation, first of all, but of course there will be more time to discuss. So first of all, I will try to present why and why are we including the FEC in SCHC. Give a bit of information about the context. Then I'll present the draft itself. I'll start by giving a high-level idea, and of course, why we want to use it is because there are real-life use cases, real deployments that have taken place, and this is there's active interests on the on behalf of the people implementing SCHC. Namely, there's a smart metering project who require to optimize their traffic flow, and it could be fixed by or improved by the FEC. And of course, to complement the fragmentation modes. In this draft, we specify, or rather propose, the specification for a fragmentation for a FEC fragment rule format. Finally, as I said, we can have some time to discuss. So, forward error correction, basically, what it means in general as a concept. It's to send some extra data. We talk about redundancy here, so that the receiver can correct any transmission errors. Of course, this is in exchange of retransmissions. So we get rid of some costly retransmissions, which in our case, if we're implementing SCHC in LP1s, it's actually super important. In the case for IoT, of course, it increases the reliability of the links, which by themselves, of course, are not very reliable. And we can reduce downlink messages. So this is actually very interesting for several reasons regarding, for example, in certain LP1s, one may want to limit the traffic in one direction. So either uplinks or downlinks are preferred. And even if we send much more, many more uplinks, it's not that bad. And if we try to send a downlink, it's actually very costly. So in this diagram, I've just tried to quickly illustrate how can FEC help us. So in case of NOAC, for example, we just send we can repeat the information if it's not if it has some transmission errors. Of course, this makes many more transmissions for the device, which supposedly has a limited battery life. Of course, we have other fragmentation modes that are more well, less primitive. So we have ACK on error and ACK always, which implies some downlink to prevent too much uplink. And well, now we would get FEC, which is, of course, it can be, in this case, it's just complementing NOAC, but it can complement any other fragmentation mode. And the point of this is to have a compromise, like to find a balance between uplinks so that downlinks are not necessary anymore. So introducing in our draft, we specify the addition of a FEC fragmentation rule format. This new rule will be bound to an existing fragmentation rule. So here on the right, we can see an example of this. So there's a new FEC rule that will be that will exist within the same namespace of the rest of the rules, especially a fragmentation rule. So this new FEC rule will complement rule 20, and so it will inherit some of its information, for example, DTAG, FCN, etc. And it will apply the algorithm on that particular fragmentation session. So this proposal aims to complement the existing fragmentation. So it aims to recover lost fragments without additional downlink messages. And for the sender, it will just send fragments as usual. And every n fragments, it will build and send a FEC fragment, which will allow to recover any missing data. So an example of this is this diagram. It can be found in the draft. We have what would normally be a message of consisting in 2 fragments. We will include now a third fragment. Here we call it just FEC fragment. And so the fragments A and B work as usual, already defined in RFC 8724. And now we include a FEC fragment, which is contains the tiles that were, in this case, in this example, XORed from fragments A and B. And so we specify, for example, that FCN will point to the last tile in our FEC window, which is the tiles that our FEC fragment would be able to recover. So of course, there's a mathematical formula here, which tells us, okay, so with rule 30, if we got the FCN 39, that means we have 12 tiles times 2, so we can recover either 12 tiles from fragment A or 12 tiles from fragment B. And here we can know to which FCNs it is pointing to. So let's say the receiver now is only able to receive fragment A and FEC fragment. Fragment B was lost in transmission. So actually the receiver can build fragment B from A tiles and FEC tiles. That's the overall idea. This is on the receiver side, so it's practically the same information, just to picture the behavior on the receiver end. Of course, there are more examples in the draft with no losses, sparse losses, or very frequent losses. This is an example of sparse losses. So in this case, for example, the receiver receives fragment with the first fragment with rule 20, which is a fragmentation rule, regular fragmentation rule. It then receives fragment number 2, and at this point, it expects the FEC fragment. Once it got it, it will check in its state if it got the last 2 fragments or the last n fragments. So if it got it, then it just ignores this fragment. On the next round, it takes so it receives a third fragment with rule ID 20, and the second fragment that it receives, it's the FEC fragment. So this actually means that it lost. So number 4, let's say fragment 4 was not received, and so it's able to rebuild it. It's not. So I see some question here by Anna. Does a rule ID is enough to identify the fragment? So in our simulations, well, not really simulations, but in our line of thought, we think it can. And actually, this has to do with some backwards compatibility. I think I can explain this in the next slide. Yes. So of course, now there's some discussion to be done. Process actually it's backwards compatible with RFC 8724, and this is related to Anna's question. So actually, if, for example, the receiver doesn't have the FEC implementation, since rule 30 is not defined in its namespace, it will just immediately not recognize these purple packets and drop them, and the fragmentation will work as it already works. So we think that the addition of the rule ID, which is bound to the fragmentation rule, will be enough. So for out-of-sequence delivery, exactly, there's now FCN, DTAG, and mbits, which may help on it. Actually, with this information, it's because we still have a FCN. We would be able to identify this.
Alejandro, Anna is waiting on the queue. Maybe you want to.
Sorry, I didn't see it. I'm sorry, Anna. I will. Yeah, you can talk.
Yes. One thing is that when you are doing fragmentation, you are using your rule 20, for example, to say act on error or act always or whatever fragmentation you are using, and then you are in your window and you receive fragment 1 and 2, you are your rule 20 always, and when you receive rule 30, it's not in your window. So how do you know that this 30 is in your fragmentation 20? That's why I say that rule ID perhaps is not enough only to recognize your fragment. because it could be seen as another packet fragment with another fragmentation mode.
Yeah, I agree. It's a nice observation, and this is why rule 30 exists only in the rule set. So of course this is to be specified, but our objective here, like our idea, what we have in mind is that rule 30 will be bound to rule 20. So actually they're linked within the rule set, and so this is why rule 30 then only corresponds to rule 20.
Yeah, but how? How you are going to bound it? You need an attribute in your rule.
It's
You
true.
cannot do
We
it
need an
only
attribute.
with the rule ID. It's not enough. You need something
Yes,
else.
so Anna, if I can probably just say so. You can, so the way you can see here is like the DTAG, the window number, and the FCN. They are like a pointer that point where you are in your data. So like the data, the SCHC packet that comes. So it's put in a let's say in a buffer, and the DTAG, the window, and FCN are actually a pointer to that. And basically, it is that's actually quite interesting. And this is what we did when we did this work with Alejandro and with Kui. Is you are actually not at all limited. It is not limited to, let's say, sending one fragment, then second fragment, and then like the FEC fragment. You can have an algorithm that can send the FEC fragments as they wish. It's like a separate process. So if your receiver doesn't understand the FEC fragments, it can simply ignore them. But if it understands, it can actually use this information to recover the buffer.
But I think
And
it's not enough. Even if I know the FEC, I know how to treat it. I'm in window 20. I'm receiving my fragments, and now I receive 30. How I know that this 30 is part of my 20 fragmentation? I think
yes,
that is
okay, so it's
something that is missing. I don't
exactly,
know.
but this is
Signaling something is missing in your
yes.
rule.
Yes, but it's actually it's the same question as Edgar. So and it's here. So you see a
Oh,
FEC
okay.
fragment, a FEC fragment, a FEC fragment rule format. It is connected. It is bound. It is entirely dependent on the fragmentation. So here you see there is like rule 30, and it says frag rule ID 20. So whenever you receive something with rule ID 30, you know that this is a FEC fragment that is related to the fragmentation which is ongoing on rule 20.
But you cannot know it because 30 doesn't mean that. I mean, it's a rule ID. So you need something else. You
It's
need
in
to
the
link
definition.
20 to 30.
But it's a new type. It's a new type of rule. As you
Yeah,
have
it's a new type of rule, but it needs to be linked to the fragmentation 20, for example, in your case.
yes.
So if
Yes,
I
it
want
is.
link, how you are doing that?
So it would be through the new attribute, frag rule ID, let's say, within which is specified for the type of rule FEC. I'm sure if this answers your question or.
Yeah, but this type doesn't exist. So you talk about attributes.
That's
So
the
interpretation
that's,
becomes fragmentation. So
that's the point of the draft. So the point of the draft is to add this FEC type, which of course doesn't exist as of today. I agree. So we want to add it to implement the FEC functionality.
Laurent is waiting.
Yes, can you? There is one slide that I don't remember if it was next one or the previous one where you have the computation with 50 minus 50 minus 12 plus 1, and I don't understand this part. For me, if you are copying the FCN, the window, and the D tag, it means that they have to be related to what you have in the flow 20. And here I don't understand the computation.
Yeah, I agree. So here the initial thought was just to have an FCN, that a pointer. So FCN would not really work as FCN. It's just a pointer because it belongs to the FEC fragment. It would be the pointer to the last tile that we can recover. So it would point to the last one. So in this case, if fragment B contains FCN from 50 and then contains 12 tiles, that means its last tile was tile 39. And from there, we can count backwards 12 and then 12 to get either B or A respectively. But I agree. So there's a inconsistency in how, so in the concept of FCN, in which now it points to the last thing and it doesn't point to the beginning of the thing. So I agree. There's some work to be done there.
Yeah. Okay. So for me, it will be easier to keep the same value. For example, I don't know, or maybe the FCN the name should have to be changed to something to avoid confusion. But it could be better if we can keep the same identifier on both sides.
So actually, Laurent, here the thing is that you see, if you imagine that the data that is being fragmented, like you have the whole data, you have a fragmentation process that is running over that data. And so from the first fragments, you have like window, data, DTAG, and FCN, window, DTAG, FCN, right? So these are the fragments that are sent over the air. So at some point, you decide, well, the process decides to send a FEC fragment. So that's really important here about this draft. It doesn't describe how, like, at what time you send the FEC fragment. It doesn't describe, it doesn't force you to specify how you calculate the FEC. It gives you that freedom. What it describes, it is FEC, it's a format. It is a rule ID. It's a rule format. And that rule format basically says, well, there is some FEC information, and that FEC information is applicable to the tiles that are like, and there is a pointer, and that pointer is given by the window, FCN, and DTAG. So here, this specific example is for Aconera, and there for Laura from RFC 9011. So there was no DTAG, and this is why you cannot see it here. But if your baseline fragmentation has a DTAG, it will be here. Yes.
Okay, we're not talking about DTAG. It's more because there is something confusing for me. Is that you talk about fragment, and if we are in Aconera, fragment is just a vector to send tiles on the other side. And so, for example, here, if I don't have the same size for fragment A and B, how do I react to the FEC? So I think we have to go at the upper layer. So you have a fragment that carry information on the other side and do a FEC on this information.
So here, actually, the point is that whenever you have a fragmentation process, your fragments have the same size. And if the fragment size changes, then you need to reset the process. So that's described in the draft. But basically, what we have in the design here is that you have like a stationary process where the different fragments have the exact same number of tiles, so that you can apply. So here the baseline example is with XOR, like you can XOR two fragments and you get exactly the size and the FEC fragment, right?
I think it's it's something to take the assumption that fragment has the same size is very limited to some technologies.
That's a good question. I don't know. It works. Well, it's applicable to a specific use case, right? So if you have use cases where the fragments are changed frequently, the fragment size changed frequently, then I think yeah, we need to think how it works. So yes, probably you can go to the last slide here, Alejandro, and the one after.
Yep. So sorry, there was just another question that went by Armand one. FEC fragments may require acknowledgement. So if the radio conditions aren't right, you may need to acknowledge the FEC fragment several times. What do you think? So if, of course, if radio conditions aren't right, I come back to my little schema here. So of course, if we start losing either FEC fragments, well, then of course the radio link is super badly, and yeah, you might need some more downlink or uplink. So either taking behaviors, let's say borrowing behaviors from NOAC or from other from the corresponding mode to which FEC is applied to. And so in the end, of course, it's not the be-all end-all solution. It's a technique to reduce downlink messages, and we're trying to apply it as such. But if you have some other suggestions, they're welcome, of course. Hope this answers your question. But yeah, other than that, of course, now I'm, let's say, contributing from my. I want to add the word limited view of having the implementation, the SCHC implementation by Akio. And of course, this method would be very easy to implement, and we can have some testing, real life testing done. Not of course without further discussion. Of course, there are some to-dos in the current draft. So of course, from what so there are some behavior definitions to be specified in the draft. So what happens, namely, with MTU changes, how to implement FEC other than XOR. Right now, we don't define the behavior for only XOR, but we take it as an example. So of course, we're free to add other XOR methods. Sorry, other FEC methods, and properly defining the new rule data model. So yeah, that's it on the presentation. So we can have further discussion, and I think we have 5 minutes left. If any of you have questions, or if something was not clear, please let me know.
Okay, thank you very much, Alejandro for presenting this work. Yes, of course, we'll be very interested in getting feedback. So we already had some very interesting feedback here. I think that's what's really interesting here is that you know, we're talking about a new type of rule, new family of rules. So yeah, we'll continue working on that one. And of course, any reviews and any comments are more than welcome. So with this, we switch to the second presentation for today. So actually, we had to discuss this some of these points during our last meeting. We didn't have enough time, so we're continuing here today. So the work on the SCHC architecture, of course, is ongoing, and we have already started to integrate remarks and discussions from our IETF meeting, where Laurent had a very long presentation of the meeting. So first of all, like during the discussion, we said that we need to include a section on multicast to address it, and one of the points was to so we discussed the use of SCHC data unit. So in the presentation, we were talking about SCHC transmission unit, so which is called STU. But I think that that was not really, like Carles suggested to use a SCHC data unit. So we said, okay, let's do that as a SCHC data unit. And during the last discussion, we said, okay, how about SCHC datagram? So we're not sure for the moment. I think that for the moment, what we discussed was SCHC data unit. So how do you feel about using the word SCHC data, the term SCHC datagram, to signify SCHC packet or SCHC fragment? Yes, Laurent?
So I think it's very important to have this, because we have to say that SCHC is not changing the internet, and we still have datagrams. So I think it's a good name, especially also if we say that SCHC can be applied to layer 2 or layer 3. So with datagram, we are more generic than SCHC packet.
Oh. Yes. Okay. So we have one remark from Eric, who says PDU. So SCHC PDU. Yes. Carles?
Yeah. So I think, well, my comment about SCHC data unit was kind of in the line of PDU somehow, data unit. I think data unit is somewhat the most generic thing, the most generic term I can think about. I think datagram has some implications of different protocols where it's already used. So yeah, I would lean to something rather sort of data unit or PDU, something like that.
Okay, thank you. So yes, Eric on the chat says that we have the case of UDP datagram, which can be fragmented, and yes, datagram is a transport term. So what I'm hearing is that there is this option of SCHC datagram, but there is probably something more of more acceptable as a SCHC PDU. SCHC PDU does that sound okay? I'll take that to the mailing list. So I'm noting SCHC PDU. Okay, and we have a Laurent also as a +1. So SCHC PDU it is. And just to be sure where we are, like we have of course a lot of things to do on the SCHC architecture, and we are advancing there. But one thing is, like in an architecture document, basically it says, one of the things is it says what you cannot do. So so we are really careful of when we describe things to say, okay, well, not to remove things that are possible. This is one of the things, and the other thing is to actually use the right terms, because we were a little bit like discovering also SCHC in RFC 8724 and subsequent RFCs. So I think it's important, in my opinion, to have to find the right terms with which we are comfortable. And I'm also, like, we are insisting into coming back to the working group, because sometimes it's just like, okay, well, it's a point of view, and I think I believe it needs to be shared by the working group. Okay, so I'm writing down SCHC PDU. Thank you very much. That sounds really great. Another point we actually discovered during a very very intense discussion, and Anna actually really defended the position that, hey, in RFC 8724, the compression stage is a must. And of course, in our heads, it's like, oh, but you can imagine doing only fragmentation, right? But when we got back to RFC 8724, well, the only thing that is in some way addressing this topic is in a very specific and formal way is figure 3. And in figure 3, we see that, well, the compression is a must, right? We do not have an entry point where we can only do SCHC fragmentation. And well, of course, you can cheat out of it, but it gives us a small technical problem. Well, it's not a technical problem. It's just that if you have to have a compression and want to use fragmentation, then that means that you need to have at least 2 rule IDs. One rule ID for the compression and one rule ID for the fragmentation. So basically, if you want to have a very simple device that only uses fragmentation, and basically you do not need a rule ID per se, so it can be 0 bits. Well, that thing will force you to use 1 bit, and the bit will be like 0. The rule ID 0 will be basically compression, and rule ID 1 will be fragmentation, and the compression will just say do not compress. So this seems like a little bit of I mean, of course, we had our reasons to do that at the time, but right now there seem to be like interest in having the fragmentation on its own in some way. So how do you feel about it? Do you think that this is a problem? Yes. Well, that's so Sergio says that you do not use compression on the SCHC over Sigfox draft. So okay, well, that's interesting. I need to reread the draft. It's an RFC now, so I need to reread it. But I mean, obviously, we meant in some way an RFC 8724 for it to be able to use only the fragmentation in some way, right? But it is not what it's written. So and we actually have another RFC that doesn't use the compression. So how do we treat that? Like, do we want to do something about it? So practically we'll need to put some information in the architecture draft, because we need to say, well, you can only do fragmentation. But how does that, like, there seems to be a contradiction with RFC 8724. So do we want to do an RFC 8724 bis or something else? I don't know. So that's probably I can yes, Anna.
Well, I think that for me, the principal problem where we are solving is the header overhead. So we want to reduce the header overhead, we need to make compression. If you are only doing fragmentation, you are diluting the IP header, but you are not doing reduced header overhead. So the objective of SCHC was to reduce the header overhead of IP to send it in the lower layer. So that's why it's must.
Okay, but we actually have a whole RFC that doesn't use it, right? And then that means there are drafts. I mean, there's a technology that needed only the fragmentation.
So it doesn't use the compression. It means that it does not reduce the header overhead. It's only doing fragmentation that is a functionality of layer 2.
Yes. Yes, I mean, I agree with this, but it's like if we have an RFC on that, so there is an errata either in RFC 8724 or in RFC 9442. Yes, Laurent?
Yes, this scheme was designed at the early stage of the group when we were in LP1 environment. And what we wanted is to have the same space for in rule ID for fragmentation and compression. So because it's optimal in this situation. Now I think that we can have also some cases where we have maybe a compression that is independent of the fragmentation. So it could be good to separate it. I don't think it's necessary to make 8724 bis, but it has to be explained in the architecture document.
Okay, yes, I see. Okay, so Eric, do you think that with the if we only like clarify this in the architecture, that it is indeed possible to have fragmentation only as per, for example, RFC 9442? Like, does that make sense?
I mean, it's not up to me to say this, right? So it's up to the working group. So because the document is a working group document, it's not my document, right? But for me, it does make sense to say, hey, sometimes we do this, we do one or the two. Could be, and you may want to state this into the document itself, in the architecture. Okay.
Okay. Yes. Okay. Okay.
Some flexibility, basically.
Yes. Yes. I mean, yes. Thank you. I mean, I perfectly understand Anna's point of view, and but it's like and what is written, but I get the feeling and that you know, and specifically like we have RFC 9442. So as I said, like basically the role of an architectural document is also to say what is not possible, right? So so yes. Anna, yes.
So you will change the name of chick. It will not be any more header compression.
Yeah, I mean, SCHC is static context header compression and fragmentation. Okay, so okay. Well, I took note for that on the SCHC architecture document. And moving on, so I wanted to get this discussion as well, because with the other authors, like, I mean, we are writing the text, and at some point is basically, hey, what do we call a SCHC instance? And I know it can sound very pedantic and very pain in the ass to bring this topic to the working group, but I yes, but the really important point is that the architecture document actually reflects the intentions of the working group, and so the discussion here is the following thing. Yeah, the architecture is shared and understood and agreed upon by the working group, and I would really like to engage like on points that are really they may seem like strange, but they in the end they have importance. So the question here, the fundamental question is: should SCHC instance be reserved for point-to-point communication, or can it be something more generic? Can it be on a like point to multi-point? And we actually have examples where we have SCHC being used for LoRaWAN, GLMS use on LoRaWAN for multicast. So we already have that pattern there. So there's this feeling that there is some, but how do we actually word that, right? And I just want to give like a short flashback, a short definition that Pascal actually wrote that, just for you to remember, like very, very intuitive. Like SCHC instance is akin to session, whereas SCHC stratum is akin to layer. Like, just, we're not going to be dealing with stratum today, but just to get back to that, to that understanding. So basically, I sent a mail to the mailing list, and these are 3 proposed versions. Like, we can iterate afterwards to actually improve the version that is chosen. But basically, the 3 versions are: the first one is saying it is point-to-point only. A SCHC instance, it's 2 SCHC endpoints. So 2 things communicating. So if we say this, that means that we will never be able to say, hey, we have a SCHC instance that is on multicast, working on multicast. And maybe we'll have difficulties explaining how MS over LoRaWAN works. So, yeah, Laurent, I can just finish and then I'll give you the word. Version B is something like, well, we can have, so we say that SCHC instance is 2 endpoints. That's for sure. And then we introduce the notion of SCHC group instance. So this is where it can be something like for the multicast, point-to-point, point-to-multipoint, or anything. And if in the architecture or anywhere in documents we want to say, hey, well, that's a sentence that that is applicable to any kind of SCHC instance, like for point-to-point instance or for point-to-point multipoint instance, then we can call it SCHC any instance. The third version is, we actually, so the version B, like the default thing is it's a point-to-point, and whenever it's not point-to-point, then you have to write it down. And version C is the default thing is like a generic thing, so it can be point-to-point, it can be point-to-multipoint, it can be multicast. And if you're dealing with a point-to-point instance, then you have to actually specify it. It becomes SCHC point-to-point instance. Now they have pros and cons, and the point is, so I've tried to summarize the pros and cons. Laurent, is it okay for you if I go over the pros and cons?
Yes, I'm on the queue. I'm waiting.
Okay, so the pros is that if we say, well, it is only point-to-point, then it's very, actually it simplifies how we write the document, and actually we really know what we're talking about. The difficulty is that, well, actually we are excluding group communication, and we can, of course, can say, well, whenever you have a multicast, then you have or a point-to-multipoint, we have hundreds of instances. Like if you have 200 points discussing it to each other, it can be factorial, like it can be, but it becomes like cumbersome. Version B, it is basically, it says, well, the default is whenever you say SCHC instance, it is a point-to-point, and whenever you want to address something else, you need to say SCHC group instance. So there is a slight ambiguity here, because it means that a SCHC group instance is not a SCHC instance. So it's just, someone reading a SCHC group instance, they should not thinking, okay, well, that things that were said about SCHC instance are applicable. So for example, if we say, well, I'm using core conf in this case to configure the other endpoint, so that's for SCHC instance. And when you say SCHC group instance, well, things that were said about SCHC instance do not apply. So a little bit ambiguous. And the third one, well, we're very strict. We're basically, SCHC instance is anything that, like, it can be point-to-point, it can be point-to-multipoint, yeah. But actually, it becomes a little bit cumbersome to write text, because in the majority of cases that we are writing, they're about point-to-point links. So every time we'll have to write SCHC point-to-point instance explicitly. So it becomes a little bit long, right? So these are the 3, and I'd like to hear, like, the working group, like, what are your feelings and your thoughts about these 3 directions? So Laurent.
Yes, sorry, I have to find the button. Yeah, for me it's a wrong problem, because if you have a point-to-point connection, and for example you have a compression rule for the address that sends all the address, you will have the same rules everywhere. With it's not a question of multicast. And if you have multicast, maybe you have the source address that will be different, and you will have different rules for each source address. So the fact that we have the same rule everywhere or different rules is not a question of what you are sending. It's a question of how you are doing your rules. And so for me, it's very important to keep the point-to-point, because as you say, there is a management, and a lot of things are made on this association between two entities. So for me, that's something that is fundamental. And if we say we can manage several rules at the same time, we don't know how to do that. So that's a problem. And if we say that we have, when we say that an instance is two entities that share the same rules, we never say that these rules are exclusive. So we can have several instances that have the same set of rules, and it doesn't change the meaning. It doesn't block things, and it's more on the question of management. And so for me, what we are doing right now is point to point. And if we want to introduce something in the future that will be group instance, I am not against adding some time in the future something working on group. But for the moment, SCHC is point to point.
For you. Okay, Marco?
Yes, hi everyone. Can you show version B?
Yes, of course, sir.
So in my opinion, this is the best one, or the one I prefer. I have a proposal to hopefully solve the ambiguity problem. You can rename SCHC instance, so the first bullet point, as SCHC pairwise instance, and then you rename the third bullet point as SCHC instance.
Okay, so I think this is close to this. I mean, and then we need, like, because it's like SCHC pairwise instance, let's say the first, which is end to point, and then you have SCHC instance, which is it what you're saying, or?
Well, the nice thing is of version B is that you have three alternatives. So they would be
Yes. Oh, yes.
pairwise group, and no need to use the word any explicitly anymore.
Instance. Okay. So okay, but so so that's a mix of B and C, where you say,
if you want, yeah.
Yeah.
The structure is like B, just renaming two of those.
Okay, but I mean, so thank you very much, and I'll try to. So I can do that. The point, of course, here is, and thank you very much, Eric. Is SCHC, like is SCHC specifically for point-to-point or pairwise, or can it be used for other things? In which case, for me, like the architectural document and terminology that we use needs to reflect that, right? And if we say from the start, well, SCHC instance is only point-to-point or pairwise, then like it locks something, right? Then it becomes like a so. Well, thank you very much, Marco. Does anyone have any thoughts on these? Anyone else on these? So it is the top of the hour. Please send an email on the mailing list saying, "Hey, well, this one fits me more." Like, I don't think that here we have a right or a wrong answer. Like, it's going to change the way the wording of the architectural document happens, right? But I think that it's important that we actually understand the wording, and we agree on that. So I will invite you just to send an email on the mailing list and say, well, mostly A, B, C, or I'm going to add D, what Marco suggested. So like A, B, C, or D, and we know, like, we can we can rediscuss afterwards. Yeah, and I just sent yes. Thank you very much. But the mod I'll need to process that. I think that the mod. Okay, I'll reread that, and I think that she said okay, modified A. Well, it's top of the hour, guys. So I'm going to send an email then to Anna, and we'll have like A, A bis, B, C, and D, or A bis, B bis, and C, and just like +1, whatever you like. You can have more than +1s, you know, the way you feel it. So thank you very much, and thank you very much to Marco and all the note takers.
Bye.
Bye.
Bye-bye. Thank you.